Good morning, afternoon, or evening. My name is Alex Lemire. I am a senior computer science student with the Department of Computer Science at UTSA. This program has been an amazing time to start a research project that I've actually been thinking up and having as a pipe dream for a couple years now. And I'm really grateful to the computer science department at UTD for the opportunity to actually be able to bring this research kind of to life. My paper and my presentation will be titled Leveraging Machine Learning Techniques for Network-Based Intrusion Detection and Prevention Systems. And without much further ado, let me get this out of the way, and let's get started. First, the abstract and core ideas. As most presentations I've seen this year have started, let me give a little ChatGPT introduction. This is what ChatGPT spit out as my shortened abstract for my paper, just to make it a little more digestible for a slideshow. The abstract and core ideas of my paper are machine learning techniques can be leveraged to improve and enhance existing network intrusion detection and prevention systems, namely through adapting the database of malware signatures in order to make them more processable and more comprehensible to the prevention systems, and to further update the intrusion prevention systems both dynamically and in real time to lower false positive rates and as well as improve anomaly-based detection. Here are some of my favorite sources that I have in my paper currently. These two sources go over, in their own very interesting ways, different approaches to this same topic with slightly different classifications of their respective machine learning models. The first one goes over mainly deep belief networks, which are entirely unidirectional, while the second one goes over excuse me. The second one goes over current neural networks, which are essentially the same system, simply recursing on itself at each layer within. These sources are both linked to the end of the presentation for clarity. The synthesis of the research that I have found is primarily that while this process cannot be optimized or enhanced, can be optimized or enhanced using machine learning, it cannot be completely automated. These diagrams will demonstrate sort of the same situation I was explaining with the research previously, where they're very similar models with a single input layer, multiple hidden layers within, and one unified output. However, in the recurrent neural network, as you can see from the diagram, there will be some looping within the hidden layers in order to improve the data before the output, whereas in the recurrent in the other, it just passes through in a single straight line. Proposal methodology for the paper presents a little more complex, and I've built a little bit of a diagram to help explain this. If you'll direct your attention to the large orange sticky titled network traffic, this is supposed to represent just classical network traffic, normal activity, intrusions, everything. The network intrusion detection system passively analyzes all network traffic, and on any detected intrusion will pass a ticket including whatever packets or protocols were used in this intrusion to the machine learning model that will then use a classifier and adversary model, which is a common model in the sphere of machine learning, in order to properly identify and classify whatever intrusion has been detected. The classifier will then pass that on to the intrusion prevention system, which will handle it according to preset protocols, and also create a trouble ticket or log that sysadmins can review, and will also be boiled down into a signature report, which will go back into the intrusion detection system. This is not the only way the detection system is enhanced as well. If you'll notice from the machine learning model, which is this sector on the right-hand side in the white box, the classifier and adversary are two unique machine learning models that challenge each other to improve their accuracy. The adversary is continually fed signature reports once they have been processed back to the intrusion prevention system in order to get fresh, real data that is then, for lack of a better term, boiled down and resorted into a new form of a new data point for the adversary to generate and for the classifier to attempt to classify. The classifier even scores the adversary based on its accuracy with real data and can better detect real data, genuine data, natural data from the network relative to the synthetic data coming out of the adversary network. The classifier will also then pass its updated malware signatures to the intrusion detection system in real time. So both systems are being improved at every intrusion and during every intrusion. Here are the reference slides, and I forgot the contact info, so I will attach that to this video.